Welcome back to All Sorts Podcast, where curiosity sets sail and knowledge is the wind in our sails.
Glad to be here.
Today, get ready, because we're diving deep into something that's reshaping our energy landscape.
That's right. We're tackling wind power, looking at the technology, the economics, and the environmental side of things.
It's a huge topic, really. Ancient force,
Yeah,
but totally relevant for our future.
absolutely. And on All Sorts Podcast today, our deep dive aims to understand it better, understanding wind power, technology, economics, and impact.
Yeah, it really sits at that crossroads of, engineering, money, and planet health.
Exactly.
And to do this, we've pulled together a lot of information. We looked at stuff from the U.S. Department of Energy, their wind exchange, and the EIA.
The Energy Information Administration?
Right. Plus the European Investment Bank, PDH Online for some technical bits, Wikipedia for the overview, and a review from Renewable and Sustainable Energy Reviews.
So a good mix of sources: government, finance, technical, academic.
Definitely. And our mission for everyone listening to All Sorts podcasts, to cut through all that noise.
Yeah, give you a clear picture how it works, the real costs and benefits, the environmental stuff, the good and the less good, without getting lost in jargon.
Okay, let's start with the basics then.
Yeah.
How do those giant turbines actually capture wind and make electricity?
Well, the core idea is pretty neat. The wind blows, pushes against the blades,
Right.
makes some spin. That spin turns a shaft, connects to a rotor,
Okay.
and that rotor drives a generator. That's the bit that turns the spinning motion into electrical power.
Simple enough when you put it like that.
Yeah.
But where does the wind itself come from?
Yeah.
It's not just random, is it?
No, not at all. It's actually a form of solar energy, believe it or not.
Solar. How so?
The sun heats the earth unevenly. Different surfaces, land, water heat up at different rates.
Ah, okay.
That, plus the earth spinning, creates differences in air pressure. Air moves from high pressure to low pressure.
And that movement is wind.
Precisely. So indirectly, it all comes back to the sun powering these things.
Huh. Sunshine powering giant spinners. I like it. Now, most turbines we see look kind of similar. Are there different basic designs?
Yeah, fundamentally two main types. The ones you see most often are horizontal axis turbines.
Ones with like 3 blades facing the wind.
Exactly. They point upwind. They have this thing called an active yaw system. Basically, it turns the main housing in the nacelle to always face the wind, maximizes the capture.
Makes sense. And the other type?
That's the vertical axis turbine. They look quite different. Think like an egg beater shape sometimes. That's the Darius type.
Okay, I think I've seen pictures.
Their big advantage is they're omnidirectional. They don't need to turn to face the wind. They can catch it from anywhere.
That sounds really handy.
Oh.
So why aren't they the main ones we see everywhere? Why the horizontal ones?
Good question. For the big utility scale stuff, especially here in North America, what they call the Danish concept really took hold.
The Danish concept.
Yeah, it's that specific combo. Horizontal axis, 3 blades for aerodynamic efficiency, upwind orientation with the active yaw.
Right.
A gearbox to speed up the rotation for the generator, usually an asynchronous induction generator, which is pretty robust.
Okay.
Producing AC power, maybe 550 to 690 volts. Then a transformer steps it up for the grid. That setup just proved really reliable and efficient for large-scale power over the years.
Gotcha. So that specific design became the standard for big projects. Now, wind isn't constant, obviously. How does that variability affect how much power a turbine actually makes?
Yeah, that's key. Every turbine has a power curve.
Yeah.
It basically shows how much power it makes at different wind speeds.
Okay.
Typically, they start generating around, say, 9 miles per hour, maybe 4 meters per second.
Right. A decent breeze.
Yeah. Then power output climbs until it hits its maximum or rated power at around maybe 29 miles per hour, 13 meters per second.
And after that,
Yeah.
if the wind gets stronger,
It'll try to maintain that rated power, but if the wind gets really strong, like 56 miles per hour or more,
hurricane territory nearly.
well, yeah, strong gales, then it shuts down automatically for safety to prevent damage.
Right. Self-preservation.
Yeah.
So because the wind varies so much, they're not always producing their maximum possible power.
Exactly. Even at a good windy site, when you average it out over a whole year, a turbine might only produce about 35% of what it could produce if the wind was perfect all the time.
That's the capacity factor I've heard about.
That's the one. Around 35% is typical for good onshore sites. It reflects that real-world wind variability.
Makes sense. So we've talked mostly about the big ones, but they come in different sizes, right?
Oh, absolutely. You've got the utility scale ones we've been discussing, 900 kilowatts, up to 2 megawatts, even bigger now.
Huge.
Then smaller industrial scale, maybe 50 to 250 kilowatts.
Yeah.
For like a large factory or facility,
No.
and then residential scale? Under 100 kilowatts for homes, farms, small businesses.
And what about those ones out at sea?
Yeah.
Offshore wind. And I think I read about airborne ones.
Yeah, lots of innovation there. Offshore is huge now. Turbines fixed to the seabed mostly.
Right.
But floating platforms are really coming along. That opens up much deeper water, huge potential.
Floated wind farms.
Wow. And yes, airborne wind, kites, tethered wings, drones, trying to tap into stronger, steadier winds way up high. Still more experimental, but definitely being worked on.
Fascinating stuff. Okay, just to quickly recap the common ones, we see the main parts of those horizontal axis turbines.
Sure, you've got the rotor blades, obviously carefully shaved airfoils.
Like airplane wings.
Kinda, yeah. Then the nacelle, that boxy bit at the top holding the beer box generator controls.
Right.
And the tower holding it all up high to catch better wind. You know, those blades can be massive, 20 to 80 meters long. And the hub height where the nacelle sits, often around 90 meters. Big structures.
Definitely impressive engineering. Okay, let's switch gears. What about the economics? The money side of wind power, what are the benefits?
Well, they're pretty significant. Jobs, for one. Manufacturing, construction, maintenance. Lots of direct and indirect employment.
Good for local economies.
Big time. Plus, landowners, often farmers, get lease payments for hosting turbines. That's stable income, especially helpful in rural areas.
Yeah, I can see that.
And communities often get increased tax revenue, which helps pay for schools, roads, local services.
And for consumers, does it affect electricity bills?
It can, definitely. More wind power can help stabilize or even lower electricity rates over time because the wind is free, unlike gas or coal, which fluctuate in price.
That's a big plus. Stability in bills is always good.
And a key part of financing these big projects is something called a power purchase agreement, or PPA.
Right. PPAs, how do they work?
It's basically a long-term contract. The wind farm developer agrees to sell power to a buyer, usually a utility,
Okay.
at a fixed price for a set period, like 20 years. This gives the developer predictable income, which they need to get loans to build the project.
And the utility gets a guaranteed price for clean energy.
Exactly. It locks in a price, hedging against volatile fuel costs. It's been crucial for getting projects built.
And haven't the costs of these PPAs come down a lot?
Dramatically.
Yeah.
Technology got better, manufacturing scaled up. I mean, back in 2019, the average wind PPA price in the U.S. actually dipped below 2 cents per kilowatt hour.
Wow, that's cheap.
Especially when you factor in things like the production tax credit. At that point, new wind was often cheaper than building new fossil fuel plants.
Incredible turnaround. What about smaller turbines? For a house or a farm, can they save money too?
Yes, absolutely. That's distributed wind. Generating power right where you use it offsets what you buy from the grid.
Like putting solar panels on your roof, but with wind.
Similar idea. It hedges against rising electricity rates. Think about remote places like in Alaska. Shipping in diesel is incredibly expensive. A small wind turbine can make huge economic sense there.
Yeah, that's a clear case. What if your little turbine makes more power than you need sometimes?
That's where net metering often comes in. If your state or utility allows it, the extra power goes back to the grid and you get credited for it on your bill.
So your meter runs backwards, essentially.
Basically, yes. It's a good incentive for people to invest in these smaller systems.
And for whole communities thinking about bigger projects, are there resources to help figure out the economics?
Oh, yeah. The Department of Energy's Wind Exchange has guides, like the Land-Based Wind Energy Economic Development Guide. Helps communities estimate jobs, tax revenue, all that stuff.
Good to know those tools exist.
Yeah.
And governments help push this along too, right? Incentives and things.
Definitely. Federal tax credits, state grants, loan programs, plus research funding to drive down costs further. And many states have renewable portfolio standards.
Which means utilities have to buy a certain amount of renewable energy.
Exactly. Creates guaranteed demand for wind and solar.
We also looked at Europe, especially Denmark. What made them such a leader in wind?
Denmark's story is interesting. It seems they had a long-term plan. They're really focused on creating market demand, encouraging investment, fostering competition between turbine makers.
So policy driving the market.
Pretty much. And institutions like the European Investment Bank were key. They provided huge amounts of funding, which built confidence. In 2023 alone, the EIB put over 21 billion euros into clean energy, with almost 3.4 billion just for wind.
Wow, that's serious investment.
That kind of long-term commitment makes a massive difference.
Okay, so technology and economics covered. Now, the big one, environmental impact. It's called green power, But are there downsides?
It's a really important question. Compared to fossil fuels, the environmental footprint is much, much smaller. That's the main thing.
Right. No air pollution during operation?
No greenhouse gases causing climate change, no pollutants causing acid rain. That's huge.
What about making them, though? Manufacturing, transport, that takes energy, right?
It does. But the energy used to make and install a turbine is typically paid back, energetically speaking, within just a few months of operation by the clean energy it produces.
So the net benefit kicks in pretty quickly.
Yeah, relatively fast over its 20, 30-year lifespan.
And can we quantify the pollution reduction? Like, how much CO2 is avoided?
Studies have done that. One example estimated a typical wind farm avoids something like 3,251 short tons of CO2 per year compared to fossil fuels, plus cuts in NOx and SO2.
Significant numbers. What about water? Power plants often use tons of water for cooling.
Another big win for wind. Turbines use practically zero water to generate electricity, maybe tiny amounts for cleaning sometimes.
Compared to?
Compared to nuclear or coal plants, which can use half a gallon or more per kilowatt hour for cooling. Even efficient gas plants use a fair bit. Wind's water footprint is minuscule.
That's a massive difference, especially in dry areas. Okay, but the issue everyone talks about, wildlife. Birds and bats. What's the reality there?
It's definitely an impact, and it needs careful management. Turbines do kill birds and bats through collisions. The rates vary depending on the location, the species.
But how does it compare to other things that kill birds?
That's the crucial context. Studies consistently show that other human activities kill far, far more birds. We're talking about cats, buildings, cars, power lines, hunting.
So wind turbines are a factor, but maybe not the biggest one.
Relatively speaking, no. One estimate put turbine fatalities at maybe 20 birds per year per 1,000 milliobu installed. Compare that to hundreds of millions killed by cats annually in the U.S. It doesn't mean we ignore it, but perspective is important.
Understood. What about bats? I hear that's a particular concern sometimes.
It is. Bat mortality can actually be higher than bird mortality at some sites. Raptors, eagles, hawks are also a concern, though their numbers seem to be generally lower than small birds or bats.
Are there things that make a specific site riskier? Design factors.
Yes. Location is key, avoiding major migration routes or feeding areas. Lighting on the turbines can be an issue. Steady lights attract migrating birds and insects bats feed on, especially in bad weather. Weather itself plays a role. Birds might fly lower in fog or clouds. Even tower design matters. Older lattice towers could offer places to perch or nest, increasing risk near the blades.
So what's being done to reduce these risks?
A lot, actually. Careful site selection is number one, following best practice guidelines, using radar or other tech to detect wildlife and shut turbines down temporarily during high-risk periods.
Smart turbines, basically.
Getting there. Also, using tubular towers instead of lattice, and researching different lighting schemes, flashing lights, maybe even lights birds can't see well. It's an active area of research and mitigation.
Good to hear solutions are being worked on. What about noise? Are they loud?
Modern ones? Not really, at a reasonable distance. Standing maybe 1,000 feet away, the sound level is often compared to a refrigerator humming.
Okay, so not usually a major disturbance for neighbors then.
Generally not. Visual impact is more subjective, though. Some people find them graceful, others find them intrusive.
Depends on your perspective and maybe how close you are.
Right. Factors like color, size, distance, blade movement. And then there's shadow flicker.
Ah, yes, shadow flicker. Explain that.
It's when the sun is behind the turbine and the rotating blades cast moving shadows that can flicker across nearby windows.
I can see how that would be annoying.
It can be, but it's predictable. You can model where and when it will happen. So you can site turbines carefully or program them to shut down briefly during specific times if flicker would hit a nearby house. Sometimes sensors are used too.
So manageable through planning and technology. It sounds like overall the environmental impacts are real, but generally much lower than fossil fuels, and there are ways to minimize them.
I think that's a fair summary. Careful planning is key.
Okay, let's look ahead then. What's the future shaping up to be for wind power?
It looks really strong. Growth is significant globally. In Europe, like we said, wind generated more power than gas for the first time last year. That's a milestone.
Wow.
Offshore is where a lot of the massive growth is expected. Both fixed bottom and especially floating turbines unlocking deeper waters. Big projects planned in the North Sea, Baltic, even the Mediterranean now.
Seems like offshore has huge potential. Any roadblocks?
Permitting can still be slow and complex. Streamlining that is a big focus to speed things up.
Bureaucracy, always a challenge.
Yep. And technology keeps advancing. Turbines are getting enormous 15 megawatts and bigger, blades longer than football fields, and those airborne concepts are still developing too.
Giant turbines. What about the stuff needed to build them? Materials. Any wordies there?
They do need a lot of steel, fiberglass, copper, some rare earths for certain generator types. Demand is rising, obviously.
Sustainability concerns.
There's definitely more focus now on sustainable sourcing and, crucially, recycling, especially the blades, which are tricky composite materials. Developing cost-effective recycling is a big push.
Right, closing the loop. What about maintaining existing farms, and what happens when they get old?
Good maintenance is vital for their long lifespan, 20, 30 years typically. As older farms reach that age, we're seeing more repowering.
Replacing old turbines with new ones.
Exactly. Put fewer but much more powerful new turbines on the same site. Get way more energy out of it. And like we said, figuring out how to recycle everything at the end of life is becoming standard practice.
So the industry is thinking about the whole life cycle now.
Absolutely. It's maturing, becoming more sustainable in every sense.
Well, this has been incredibly insightful. We've gone from how the wind makes them spin to the dollars and cents, the environmental picture, and now the future. Quite a journey.
It really is a fascinating technology, mature in many ways, but still evolving fast, definitely cost-effective now, with major environmental upsides compared to the alternative.
Yeah, the impacts are there, but they seem manageable and are being actively worked on.
Exactly. The innovation continues.
So next time you feel that breeze, maybe think about its potential journey from a gust of wind to powering our lives. It's a powerful story of harnessing nature.
A great way to think about it. The story's definitely not over yet.
Definitely not. And if this deep dive on All Sorts podcast got you thinking, if you're feeling that curiosity, then head over to the All Sorts podcast on YouTube.
Yeah, check it out.
Like this exploration, share it around, and definitely subscribe to All Sorts podcast so you don't miss our next adventure into understanding our world. Let's keep building this community.
And don't forget our back catalog on All Sorts podcast. We've explored lots of other cool topics already. Dive in.
And for those daily sparks, catch All Sorts podcasts on X, Instagram, and Threads. Join the chat, share your thoughts. Let's keep those winds of discovery blowing.